I am Anil Kumar. In this video, we'll discuss price elasticity of demand, understand few terms, their definitions, and then take a few multiple choice questions for practice. So this video could be about half an hour long. So let's begin by understanding the basic concept of what happens when we reduce the price. So if I take up a scenario where price and demand are related by, let us say, a graph like this, something like this, where price is along the y-axis and x, the number of items sold for that particular item, are shown on the x-axis. Then you can see that if we reduce the price, so let us take a price at a particular level. Let's say this is one standard price. Let's call this as P1. At this price, we are able to sell X1 number of items. Now what happens if I reduce the price? If the price is reduced, let's say it becomes P2, so it is much smaller than P1, we will see that the number of items sold are higher. So what you can also see here is that for a higher price reduction, there could be a change in, I should say, in consumption, right? So there is a relation between price and consumption. Now this relation is very important for economists. And so we have few terms here which we need to understand and some business scenarios. So whenever there is a change in price, there will be a response from consumers, right? That could be in the form of increased sales, for example. Now, rate of change of price may not directly reflect on rate of change on the number of items being sold. That's a different issue. But what we expect is lowering price may increase the number of items being sold, right? So that's one thing. Now, second thing we talk about is elastic demand and inelastic demand. Now, in that case, we are talking about revenue. Whenever you multiply price with the items being sold, we get revenue, right? So we can say revenue is price times items being sold, correct? Now, in that case, for revenue, you can see that, let's keep items here on the x-axis, that sometimes that the revenue will basically product of P and X. So when, of course, it is zero, then you will see that this graph normally will be kind of like this. So for some particular price, it will be maximum, as you can see from this particular graph. So initially, when you reduce the price, more number of items are sold, and therefore net revenue is higher, right? So it increases. But there is a limit to this. At one point, increase in price may not reflect on increase in the sales to that extent, correct? So what you see here is that the tangents drawn at different points on this curve, initially they have positive slope. Then it becomes lesser positive, zero at a point. And after that, the revenue is kind of decreasing. What we're trying to say here is that with every item sold here, you make more revenue. And on the other hand, if the price is further reduced, you may actually incur some loss, right? So that is what it shows. So in this scenario, if the rate of change of revenue is positive, that means on the left side, then we call this as elastic demand. So this left side here will be referred to as elastic demand. And on the right side of this, we'll call this as inelastic demand. Algebraically, we'll say rate of change of revenue with respect to items is greater than zero. That means positive slope on this curve. that means elastic demand. And if it is negative slope, then it is inelastic demand. You can observe that where dr dx is 0, at that time we may be making maximum revenue. So this point could referred to as maximum revenue. So we'll have some examples to understand this concept in details. Now, let me define the elasticity of demand. Elasticity of demand is the ratio of percent change in quantity demanded, X, to the percent change of price change, right? And mathematically, it is written in this form, where this Greek symbol is eta, ETA. So we say eta equals to P over X divided by dP over dx. So we can do some derivation of this, just few steps to go. As we understand here that elasticity of demand is ratio of percent change in quantity demanded. That means eta is equals to percent change means change in quantity over actual, right? So let us say x1 was actual. Change is x2 minus x1, right? That is the change we're talking about. So this is delta x for us, and that is delta p. Do you understand? That is the change in price, and this is the change in demand. So it is the ratio of change in the quantity demanded, which is x, change in x, to the percent change in price. That means this percent change. So let's call this as delta p over p. Whenever we are talking about percent, we have to always divide by the actual price at that time, correct? So that gives you the formula, which I can rearrange and write this as, taking this p to the numerator. Well, let me write it like this. Delta x over x times, so if I write it as times, I could write this p over delta p. Is it okay? Now, we could rearrange this and write this as price over number of items being sold. Let's say P1 over X1 divided by, so in the denominator, we have delta P divided by delta X. Change in price over change in demand. So see how it flips, right? So we ultimately have this formula which says for a very small change in price, a small increment, we could change this delta to dp dx, right? dp dx. So that becomes the derivative. And we can use now all what we have learned in calculus to find maximum, minimum, rate of change, optimization, and all those things, correct? So this formula is really very handy to use. And we will see how it can be applied in easily finding solution to many questions. But I hope this part is absolutely clear. So let me summarize that whenever you reduce the price, we expect more items to be sold. Well, a word of caution here is not always, right? So not always. Let me write down. So let me say a change in price, that means if price increases, then the demand decreases, right? That is true, right? Also, if the price decreases, let me write, price decreases, then number of items increases. That is true. However, revenue, which is the product of price and the number of items, may or may not increase with that rate, right? So the revenue, which we call this as rate of change, that means dr, with respect to dx, may be greater than 0, may be less than 0, or may be equal to 1, correct? May be equal to 0. So there could be 3 different scenarios as far as revenue is concerned, which is product of price and the items being sold, right? So that gives rise to these 3 kinds of terms, which is elastic demand, inelastic demand, and and the maximum revenue, right? When it is 0, we'll see that it is maximum revenue. Okay, now let us take a few multiple choice questions and understand how to solve the questions based on price and demand. So here is the first question for you. The demand function of a product is x equals to 20 minus 2p square. If price is increased from 2 by 5%, find the percent change in quantity demanded. Round to whole number, right? 4 choices are given to you. So these are your 4 choices. I'd like you to pause the video, answer the question, and then look into my suggestions. Now in this particular case, let's look into the scenario. So what we are given here is that x is dependent on price, and the parabola, looks like a parabola, right? Where 20 is when price is 0, and as price increases, it decreases, correct? So as expected, it will be kind of a parabola like this in that scenario. So that is how you could sketch it. Now it says that if the price is increased from 2 by 5%. So let us say this reflects a price of 2, right? Let us say. So it's not to the scale, but this is 2 for us. Now if the price is increased from 2, that means if the price is now equal to 5% plus 2, kind of, let me use another ink. Let's say like this. Then the number of items sold will be lesser, correct? So as you can see here, the number of items are being represented on the x-axis, since, this is the price here in this case. Well, normally we write x items here, but anyway, both are same. So we are writing x as a function of price, so I'm writing price here on the x-axis. So price has increased by 2%, 5% from 2. So for x1, let's say this value is x1 when price is $2. So that is equal to 20 minus 2 times 2 square, which is 20 minus 4 times 2 is 8. So we get 12. So x1 is 12 for us. Now it says it is increased by 5%. So what is P2 equals to? We know P1 is equals to 2. So P2 is 5% more than 2. So it is 2 plus 0.05, that is 5% of 2, right? So which is 2 plus, when you multiply this, you get 0.1, right? 5 times 2 is 10, so we get 0.1, which is 2.1, correct? So P2 is 2.1. What is x2 equals to? Substitute this value in the formula. So we get 20 minus 2 times 2.1 whole square. So let's use the calculator to find this answer. 20 minus 2 times 2.1 square is equal to, decimal value is 11.18. So we get 11.18, correct? So 11.18 is this x2. This is our P2. Perfect. So for a change in price, which we are increasing, there is a decrease in demand. Do you see that? So we want to find the percent change in quantity. So percent change in x is how much? It is x2 minus x1 over the original price times 100, correct? So let's calculate this. 11.18 minus 12 over 12 times 100. So this is equal to, so we already have 11.18 minus 12 divided by 12 times 100 equals to, in decimals, 6.83 with the negative sign, minus 6.83, right? So that is expected. Since with increase in price, demand decreased. Minus 6.83, when you round to whole numbers, you get minus 7. Okay, so minus, we are trying to, a higher number, it means more rate of change. So we'll take this as D as our answer, right? Okay, so that becomes the answer for the first question. Now let's look into the next question. The demand function of a product is, so we are talking about the same demand function, okay? Now question number 2 here is, the average elasticity over the interval 2 to 2.1 is what? Now we have to find average elasticity. So what is average elasticity? Well, here we have defined it. Average elasticity of demand is defined by the percent change in quantity divided by percent change in price. Correct? So for these values, 2 and 2.1, we just calculated the values. That is, we are talking about 2 points now. So let's say for a value of p, what is the value of x? So for a value of 2, we found x as 12, correct? And for a value of 2.1, we, in the previous example, it was 11 point something. So what is that? 11.18, right? 11.18. So now it says that what is average elasticity? Average elasticity of a demand is defined by percent change in quantity divided by percent change in price. So it is equal to percent change in quantity divided by percent change in price, correct? Now what is the percent change in quantity? See, the quantity changed from 12 to 11.18. So it is equals to 11.18 minus 12 divided by the original price of 12 times 100, right? And as far as the percent change in price is concerned, price changed from 2 to 2.1. So it is 2.1 minus 2 over the original price of 2 times 100. So that is how you can find this particular ratio, correct? Now let us do the calculation. So what we have here is 11.18 minus 12 divided by 12 is equal to, let's say this is minus 41 over 600. And in the denominator, we have 5%, which is 2.1 minus 2 divided by 2 is equal to 1 over 20. So it is 1 over 20, correct? So that's what we get. So the exact value, you could calculate it as 30. So let's use calculator to find decimal equivalent since the answers are rounded. So we have a negative value 41 divided by 30 as equal to, in decimals, 1.36. So 1.36 negative, we'll round this to 1, correct? So we get our answer as B. So that becomes the average elasticity option 1.36 rounding to 1 with a negative sign. Question number 3. The demand function of the product is x equals to 20 minus 2p square, and this time we'll find elasticity for a price of $2. 4 options are given to you. Now to find elasticity, we can use the formula neta is equals to p over x over dp dx, correct? And find elasticity. Now for a value of p equals to 2, we know x is equals to 20 minus 2 times 2 square, which is 12, right? 20 minus. So we have p and x values. We need to find dp dx from the given expression. Now the best way is, those of you who have done implicit differentiation, they do not have to rearrange it. You can write the equation as x equals to 20 minus 2p square and differentiate both sides with respect to x. We need dp dx, right? So we'll differentiate with respect to x on both the sides. So we get dx over dx, which is 1, equals to, this is 0, minus 4p dp dx, correct? So what we get here is that 1 is equals to minus 4p dp dx, or what is dp dx equals to? minus 1 over 4p is equals to dp dx, correct? So when p is equal to 2, the price is 2, this value dp dx is equal to minus 1 over 4 times 2 or minus 1 over 8, right? This is for p equals to 2. So we have this value for p equals to 2. So the elasticity for the demand is equal to p is 2 for us, x is 12 over dp dx, which is minus 1 over 8, minus 1 over 8, correct? So what we get here is 1 over 6 times, we could write this as 8 over 1 with a negative sign, right? So that gives us, dividing both by 2, 4 over 3, negative is the answer. So option A is the correct option, correct? Let's move on to the next. Now we'll do question number 4, which is regarding revenue for the same function. The question here is, the demand function of a product is x equals to 20 minus 2p squared. Find the value of x that maximizes total revenue. Now revenue is equals to x times p. Now we are given x in terms of p, so we could write this as x times 20 minus 2, I should have written x in terms of p, so x, let me rewrite this. So what we are given here is x value, which is 20 minus 2p squared times p, right? So that becomes the revenue. Now we need to find the value of x that maximizes total revenue. So we'll differentiate first with respect to p. So we'll find the price for which we'll get maximum revenue, and then we'll find x. Okay, so we'll do the other way. So we'll differentiate with respect to p. So let me rewrite this as revenue equals to 20p minus 2pq. So dr dp, see, we are differentiating with respect to price, not x, okay? Now what we get here is 20 minus 6p squared. Now for revenue to be maximum, this should be 0, right? So we'll try to find critical number now. So for critical number, this should be equal to 0. So we can equate 20 minus 6p squared to 0 and find the price. So let's rearrange. So we get 6p squared equals to 20, or p equals to 20 divided by 6 square root. Okay, so you can divide by 2 and get square root of 10 over 3. So that is the price. Remember, this is the price, and this is not the x value. X value is equal to 20 minus 2 times p square, which is square root of 10 over 3 whole square, right? So which is 20 minus 2 times 10 over 3, right? So that gives you the answer as, so this becomes 60 minus 20 over 3, and that is 40 over 3. So 40 over 3a is the correct option, correct? So what we did here is, we did not rearrange the equation. You could have done that also and written in terms of x. Rather, we differentiated the equation with p, found the price for which we'll get maximum revenue, and for that price we found out how many items are being sold, and that's how we got our result. Now another critical thing to understand here is that how do we know that this is really a maximum, right? So for that, what we should do is we should find the second derivative of revenue, right? So this is the revenue function. Second derivative, this is the revenue function, right? 20 minus 6p squared. Let me call this as first derivative. Then the second derivative of this is going to be minus 12p. Now since p is greater than 0, the second derivative is less than 0. It is minus 12 times p, right? So that ensures that we have a maximum, since for second derivative to be less than 0 ensures maximum. So I hope that point is well taken care of, correct? So let's move on to the next question now. Now here is question number 5 based on our demand function x equals to 20 minus 2p square. The question is, identify interval when the demand function is inelastic. Now demand function will be inelastic when the rate of change of revenue is negative, right? So what we're trying to figure out now is the point where rate of change of revenue is crossing the maximum value, right? So it is kind of like this. So it is inelastic when dr over dx actually becomes less than 0. So this portion is where it is inelastic, right? So that is to say, when we further reduce the price, the items being sold are increasing, but not at sufficient rate to increase the revenue at that interval. That's what we're trying to say, right? So in the previous example, we found that 40 over 3 was the maximum value, correct? Now here we have the expression x is equal to 20 minus 2p square. Now for p equals to 0, maximum value of x is 20. So that means x is actually greater than 0 and is less than 20, right? So it is in between 0 and 20. Perfect. You're not going to sell an item for 0 cost, and therefore we are not including that value. Is that okay? You could include 0 items. Well, then you're not making any sales, so there is no demand. So normally we keep it open, right? So that is the domain for x for us. Now I'll again find the maximum value, and then we'll know the interval where it is inelastic, right? So let me rewrite our revenue as x times p, which is equals to, x is given to us, so it is 20 minus 2p square times p. So revenue is 20p minus 2p cube, that is revenue. Now dr over dp will be 20 minus 6p square. For critical number, that should be 0, and then we'll get the value of p. Let me write p square rather, will be, let's say 6p square is 20, or we can say p square is 20 over 6, which is 10 over 3. Now if I substitute this value in our expression, then we get the value for x, right? So x is equals to 20 minus 2 times p square is 10 over 3. So that gives us 60 minus 20 over 3, and that is 40 over 3. So this price is indeed 40 over 3, correct? Now if I take a value which is higher than 40 over 3, you will realize that that value becomes negative, correct? So if I take a value of p which is more than the critical value 10 over 3, it will become higher, right? So in this case, the inelastic interval will be from 40 over 3 to 20, correct? So that becomes the inelastic interval, which is interval A for us. So with this, we conclude our video on understanding price elasticity of demand. I hope it helped you. Feel free to write your comments and share your views. If you like and subscribe, that'll be great. Thank you and all the best.